Greetings, scholars. This is the first of a series I'm going to be putting together on some concepts that are pretty common in middle school math. We're going to be touching on things from negative numbers, metric systems, some geometry concepts. We'll do some higher level things. Please, if you've got any suggestions or ideas on things you'd like me to do a lesson on, let me know. I'll be happy to talk about it. All right, what do we know about triangles? All right, listen, I hope you participate in this, whether you've got a piece of rope or a dog leash like I have, or simply a rubber band. Please get it out. There will be a little bit of note-taking also, and we're going to do a little activity in a little while, which will need a piece of construction paper and some scissors. So, what do we know about triangles? Hey, 3 sides, right? 3 corners. You can make them skinny. You can make them whatever weird shape you want. Whoa, that one looks kind of nice. Pythagoras, I think I found something. You can make them real skinny. You can make it real tall. Okay, triangle's got 3 sides, 3 angles, 3 corners, right? All right, let's talk about those, and we'll talk about how to classify them, and then we'll talk about a few of the properties that are common to triangles only. First thing with triangles, the sides. All right, we call these sides segments because they're just a piece of a line. So we know what a segment is. Okay? It's got 2 endpoints. If we're talking about one on a shape, we might draw it like that. But it means it stops. Of course, the next thing up would be what a ray is. Think of a ray of sunshine. It's got 1 endpoint. Again, 1 starting place goes infinitely in the other direction. Finally, of course, we all know about a line. We use that for a lot of things, but we know a line goes forever with no endpoints. All right. The other thing, of course, are the corners of a triangle. Well, each corner, we call that a vertex. Okay, it's where 2 segments meet, or intersect, as they like to say. Now the plural of this would be of vertices. Fine. We break triangles up into different categories depending on these 2 things. What the sides look like, what the segments look like, and what the corners look like. Okay, so what we're going to do is let's classify triangles. First, let's do it by the lengths of the sides. Okay, by the lengths of the sides. Okay, you might have a nice perfect triangle where the lengths of all 3 sides are all the same. Don't pay attention to the angles right now, but if we were to measure all 3 lengths of this perfect looking triangle, and by the way, a perfect triangle I'm referring to is really called a regular triangle. Regular is the term for any polygon in which all the sides are the same length and the angles are the same dimensions. So this would be a regular triangle. Okay, so far as the lengths of its sides, if all three are the same length, we call it an equilateral triangle. So we have an equilateral. And I'm going to say that's where all the lengths are the same. In fact, I've drawn a clever little equilateral triangle. I hope you'll do something similar to that on your notes. What else might we have so far as the lengths? Well, you might have where two lengths are the same. Could be that way, could be that way, but where two of them are the same. We call that an isosceles. And again, I encourage you to draw yourself a little isosceles triangle. Cut one out of a piece of construction paper, perhaps. Two of the same lengths. Now, I say at least because, look, let's say, okay, this would be isosceles. Still staying isosceles, right? In other words, this and this would be the same length. Well, eventually that's going to approach and then equal an equilateral triangle. Well, we don't eliminate it from the isosceles grouping just because it happens to surpass that. Of course, we could go on and isosceles triangles would get even more distorted like that. So, they have at least two of the same length sides. That's called an isosceles. Well, the only other situation is if none of them have the same length. Okay, well, we call that a scalene triangle. Look, scalene triangle. Again, don't make them any the same, all different. Okay, that's all you can have to do with the different lengths of sides. There's only three possibilities. The other ways we classify triangles is by the angles. If it happens to where all three angles inside are less than 90 degrees, now those are called acute angles, then that would be an acute triangle. Less than 90. Well, another situation would be if it has one big one. That's called an obtuse angle if it's greater than 90. So we would call that an obtuse triangle. Well, now, it could be one where all three angles are the same measurement, right? Now, we've seen this a minute ago. Remember when the same three sides were the length? That's an equilateral. Well, technically, if you're only comparing angles, this would be called an equiangular triangle. But but nobody uses that term. Just call this an equilateral triangle. Well then, our final most important triangle is what we call a right triangle. One that's got a 90-degree angle, and if you look at my thumb down here, I'm trying to make a 90-degree angle. That's a very special triangle. And it's got a 90-degree angle in it. So again, we've got an acute triangle. We've got an obtuse triangle, where it's got one length that's greater than 90. And we've got our very special right triangle, where it's got a corner, a 90-degree angle in it. Alright, if you make that chart, I think you'll be in good shape as far as classifying triangles. Let's talk about angles for a few minutes. With angles, think about a circle. They took a circle and they broke it up so that if you put your mind's eye right in the middle, it would take you 360 degrees to make it one lap all the way around. In other words, if you're starting right here at the top, up here at 12, you go a little bit further. Well, since it's 360 degrees for one complete lap around, well, there's 60 minutes in an hour. So 360 divided by 60 is 6 minutes. So that means every minute on the clock, it has gone 6 degrees further. 6 degrees further. Every 5 minutes, 6 times 5 is 30, means the clock would have gone 30 degrees. So instead of being right at 12, boom, there's 30 degrees. There's another 30, so now you've gone 60. All right, you're right there, there's 90 degrees. Keep going around, 120, 150. Now, straight up and down is really as if you've gone 180 degrees. It's a straight line. It's as if you started at the top and went all the way at the bottom. All right, I'd like to talk about that today, because I'd like to do a demonstration to show one of the important concepts in triangles. And that is, there's a concept that says the sum of the angles equals 180 degrees. Well, we could get out our protractors, which we might do in a future lesson, and have some fun with stars and stop signs and things like that. And we could measure each of the 3 angles in a triangle and see if indeed they should add up to 180 degrees. But there's an easier way to check. What we're talking about, remember, 180 degrees would be one straight line. So what I'd like to do today with this to close out is let's do a little lesson. What I'd like us to do is let's see, is this really true? If it is, we should be able to add together the 3 angles in a triangle, and it should form a straight line, 180 degrees. So what I'm going to want you to do, grab a piece of construction paper, notebook paper if you have to, and make any type of triangle. Don't make it real small though. The concept is the same, but it just is easier to demonstrate if it's a large one. So I'm just going to cut any old which way. Try to make a straight line. There's one, here's another one. I'll do, let's see, I don't want it to be, I'll do something weird. Here's something. try to make this. Let's see. Huh. What kind of triangle is this? First, let's talk about it according to the sides. They all three have different sides. We don't need a measure to tell that. So, what is it? It's called a scalene triangle. That's right. Now, don't focus on the lengths of the side, just focus on these three angles. Okay? Well, remember, 90 degrees is a right angle, like a corner. Well, this is definitely a small angle. This is actually probably 10, 15 degrees. Definitely less than 90. This one here, I'd say this one's also definitely less than 90. Well, this one is bigger than 90, right? 90 would be straight up. So this would be an obtuse angle, which makes this what kind of triangle? There you go. It's an obtuse triangle. All right, what I'd like you to do is grab your marker, and I need for you to mark where the three angles are on our original triangle. Because in a minute we're going to cut it up and kind of move it around and put it together, and I want to make sure we know where our original three angles are. So what you need to do is mark your three angles, and I'm going to ask you to call them A, B, and C. Doesn't matter. Mathematicians, we kind of like A, B, and C. So I'll call this angle A. I'll call this angle B, and down here I'll call this angle C. All right. Now, again, I'm just trying to demonstrate, do these three really add up to 180 degrees? How about you? What's yours look like? I hope your triangle looks different than mine, but nonetheless, three sides, three angles. So what I'm going to do, one at a time, I'm going to cut them up. Doesn't really matter what shape I'm cutting them into. The important thing is here's the angle of the original. So there's the first one. Let's see, let me put this on the board. I'll even put her right here, right on my board. There's angle A right there. That's not really important. Angles B and C. Again, I just need to know which angle B is and angle C is. The other shape or angles are not really important. That's just how I happen to cut my triangle out. So angle B, I want to put that right there next to A. And now, let's see if it works. Here's angle C. I put angle B is right there. And then angle C, look at that, look at that, look at that. Straight line across. Okay, thank you very much. This has been a demonstration of the sum of the angles is equals 180, as well as a little talk about triangles. My next lesson is going to be a good one. We're going to talk about the Pythagorean theorem, which has to do with right triangles. A very interesting guy. Not only does he get credit for the Pythagorean theorem, of course, which he probably didn't actually think of himself, but he was also, did you know he's a very strict vegetarian? He wouldn't even eat leather. Everything had to be cotton and cloth. He, part of the reason why is because he was very strong into reincarnation. He felt like when a person died, their soul, spirit, whatever, went on to another animal. So a cow might very well be somebody's mother, so there's no way he's going to harm that. He was a very interesting guy. We're going to focus more on the concept that he had to do with the math, the Pythagorean theorem next time. Thank you very much. Stay tuned.